Alrighty, folks. So we are working through the remaining problems on the EOC packet. There's going to be several parts where I kind of leave the work to you, and then you kind of have to figure out the answer. So make sure you do that properly so that tomorrow when you're working on the online input that you get the answers correct. Okay, so it says Jane wants to determine the shortest route from her home to her workplace. She only walks on the sidewalks indicated by the dotted lines. What's the distance of the shortest route to the nearest whole block?
Please excuse the interruption. Grace Dane to attendance.
Okay, so looking at our map here, I feel like it's pretty obvious where our shortest route is. So we are looking at this route right here. So we are trying to map out this guy. I could be wrong. Correct me if I'm wrong. I believe that that is the shortest distance. Okay, so working from here, we want to add up this side, this side, this side together. Okay, so that's going to be 3, 1, and 1. Now, we also need to find these diagonal distances. In order to find these diagonal distances, I'm going to have to use the Pythagorean theorem. So, draw a triangle. This side is 3 and 2. And then draw a triangle. This side is 3 and 6. So, your job is going to be to use the Pythagorean theorem to find that blue and green side, and then you're going to add that to that distance of the red. So 3 plus 1 plus 1 is 5. Make sure you round to the nearest whole number to get this information right here. Okay, so pause the video and then go ahead and try answering that on your own. Okay, for 23, what we're going to do is we're trying to figure out, we're told that x is less than 90, y is less than 90. So x and 90 are both not 90. It tells us that sine of x and cosine of x and sine of y are equal to each other. Well, hopefully you already know what that relationship is, but if you don't, we can draw a triangle. So if we draw a triangle here, there is a relationship, right? X and y cannot be this angle. They can be these two angles. And I want you to pay attention. This can be drawn anyway, as long as it's a right triangle. So don't pay attention too closely to like how it's specifically drawn. It's just random. Most of the ones I draw tend to look like 30, 60, 90 or 45, 45, 90. That's not necessarily true. We're looking for the relationship between this angle and this angle in terms of the angle measures. Well, all three of the angles, 90 plus the x plus the y, are going to equal to 180. So from there, go ahead and solve to get an x equals equation, which you'll plug in down there. Okay, so pause the video again and go ahead and solve for x. All right, our next problem, 24. Two events A and B are independent. Gives us the probability of A is 0.3 and the probability of A and B is 0.24. On your formula sheet, which you do not have in front of you, actually never mind, that's A or B. For A and B, we should know when we see the word and, right? Given is division, or is addition, subtracting out the overlap, and means we are multiplying. So that means the probability of A times the probability of B is equal to 0.24. Well, we know the probability of A. Just plug it in. So I have 0.3 times the probability of B equals 0.24. Go ahead and solve for the probability of B. All right, here's 25. Okay, so you can see I have this table here. I'm trying to fill it out, but I don't have enough information. So what it tells me is that a person selected at random to win a prize. The probability of selecting a female, and I'm going to highlight these, probability of selecting a female is 0.6. I do believe you're allowed to highlight on the EOC. The probability of selecting a child, given that the person is female, oh, wrong thing, is 0.25. So let me go ahead and write that out since I have it. This is the probability, so given probability of child and female divided by the probability of female is equal to 0.25. Okay? And it says that the probability of selecting a male, given that the person is a child, oh my gosh, I keep doing that. Given that the person is a child is 0.4. So let's go ahead and write that one out as well. We have the probability of male and child divided by the probability of being a child is equal to 0.4. Okay, so we're trying to fill out the two-way table. We already know some of this information. We know the probability of being a female is 0.6. So that right there, that's our P of F that we have labeled. Now we have P of F right here, so we can plug that in. Okay, so we have that this is 0.6. Okay, so in order to find the probability of child and female, all I need to do is multiply both sides by 0.6. So times 0.6 times 0.6. These guys are going to cancel. So the probability of being a child and female is whatever 0.25 times 0.6 is. So we get 0.15. Okay, now that is out of 200, so that's the probability. So the total of child and female, is going to be 0.15 times 200. So that value is 30. So I go to my child and female. Here's child, here's female, then this is 30 right here. Okay, let's try and solve what we can of our table without any of other information. Okay, so 50 minus 30 gives us 20. 80 minus 20 gives us 60. And 120 minus 30 gives us, I'm having a 90. Okay, so if we're looking at male and child over child, right, that's 0.4. 0.4 of 200 is 80. So, that's not what we need to look at. So just to kind of check our answer here, right, male and child. So this is male and child over the probability of being a child. 20 over 50 is that 40%. So worked out. Okay, so that's our answer to 25. Okay, so independent events are events that don't depend on each other or don't influence the other. Okay, he's picking fruit from a basket that contains fruit. There's some key words in each of these. Use the process of elimination to try and figure out what your answer is to that one. So I'm going to leave that one to you now that I've defined what independent means. The probability of flipping a fair coin heads up is 0.5. The probability of rolling a fair number cube with sides numbered 1 through 6 and an odd number landing face up is 0.5. What is the probability of flipping a heads or, let's just go ahead and highlight that, or rolling an odd number? Okay, well, So if we're flipping heads and we're rolling an odd number, the word or means that we are trying to find the probability of both of those. Let me just double check something really fast. Now, the way that it's written is a little bit deceiving. I think in this case, probability of flipping a heads or rolling an odd number, it's saying in one event. So I think this is truly a then statement, and I could definitely be wrong. Oh wait, you know what? That does mean or. Sorry. We're all going to make mistakes sometimes. Okay, so the probability of flipping heads, right, is 0.5. The probability of rolling an odd number, let's put D for odd, I don't know why, is going to be 0.5 as well. The formula for finding or is going to be the probability of heads plus the probability of odd minus the probability of heads and odd. So if we were to write out the whole sample space, it would take us quite a bit of time, but we're looking at those combinations for here. To find those, to find the probability of heads and odd, which I used as a D before, so I wouldn't think it was a 0. I'm going to do the probability of heads and odd is equal to the probability of heads times the probability of odd. So that's going to be 0.5 times 0.5, which is 0.25. So we have 0.5 plus 0.5 minus 0.25. And you should be able to calculate that to get your answer. So 27 is quite different than a lot of the problems that we did for probability because you have to actually figure this out after the fact. It's not given to you. All right, 28. So it's asking you to write in terms of X and Y. So our answer should have X and Y in it. And we're trying to describe the transformation. So we want to think we're going from this one to this one. So we're going how many this way? That would be our change in X. And how many this way? This would be our change in Y. So I'm going to leave the rest of that to you to write down here. All right, so this is a proof called a flowchart proof, and you've actually seen this on math Excels before. They're just not very popular in my class because I think that there are better ways to do proofs. But anyway, so you can kind of see the information kind of floating around. This is a drag and drop. Let me scroll down. You can see those drag and drop things. I just want to point out that these right here would be statements. And these right here would be reasons. And the reason we point that out, remember, is because these right here should be reasons. All three of these, sorry. And then this right here is my statement. So I've really narrowed down what I'm trying to do here. Looks like my diagram has been marked for the most part. I just want to make sure that I mark as I go here. So I have the altitude marked. I have B and C marked. Okay, so I'm kind of making a mental note that I've done that. I've got that ADC is 90 and ADB is 90. So ADC and ADB are 90. Okay, so this right here means that this step is completely separate from this one. So it's not influenced by that other piece. So we want to look for which one of these works out from what we have, given that AD is an altitude. Well, if AD is an altitude of ABC, then I don't know that AD is congruent to AB. It doesn't say it's a midpoint or anything, and I'm trying to prove it's isosceles, so I don't know that these sides are the same. So I feel like the best option is this AD congruent to AD. And again, these are drag and drop. Okay, so you should know which one of these it is, right? Which one do we have? It's going to be the reflexive property. I eat an apple, I throw an apple back up. So I've used this, and I've used this, and I don't need this anymore because I've already got all of my statements. And then I want to just go from there. Okay, looking at this, right? That's triangle congruence. These are the ones that deal with, well, actually no, these three and this one deal with triangle congruence. Let me go ahead and mark that. Okay, so based on what I have, which one is going to be the best? I do have a right triangle, which is what HL is used for, but HL you have to be given a hypotenuse. The hypotenuse would be this, so not going to use that one. I don't have 3 sides, and so I'm down to side, angle, side, and angle, side, angle, and we have 2 angles and then a side, so this is going to be angle, angle, side. So we use this one. I no longer need this one anymore because I'm not doing any more triangle congruence. Okay, AC is congruent to AB, so these 2 sides appear congruent. Okay, well, I'm between the transitive property and CPCTC. It is going to be CPCTC because I've already proven the triangle is congruent, so their parts are congruent. All right, and then here's our last problem. It's a drop down. It says we're trying to complete this statement. I'm going to zoom in here. It says circle M can be mapped onto circle N. So I'm going from N to N. And it's talking about a reflection over which axis? Well, it tells us which axis. Hopefully you're able to see it. It's this one. It literally tells you that it's the x-axis. So if you forget the difference between the x-axis and the y-axis, it's labeled for you. All right, then looking at our dilation about the center. Use a process elimination for this one. We don't have to do any calculation. It's getting bigger, so you can get rid of 0.67. 1 would mean it stays the same, so we wouldn't use that answer. So 1.5 is my scale factor. I did very little work to figure that out. All I had to use was the process elimination. All right, and that is all. So make sure you go back and finish those problems if you haven't already. And thanks for